Thank you for having me. I have a lot of slides. They're in a few different sections. Let's see. But I'm thinking that this could be a discussion as much as anything. So there's let's just look. Oh, maybe they're not in sections for this one. Oh yeah, here we go. So here's what we could talk about today. The first section, oh my gosh, that didn't work. The first section is all about lean and how lean works in construction. Yeah, it's a little blurry. The first section is all about lean and how it works in construction. The second section are some project results when we've used these techniques, how things have worked. And they're good. They're really good. The third section is an idea that we had as a company. I'm part of a big organization, HGA. We're about 800 people in the United States, architects and engineers, in 8 offices across the country. So we learned about lean. We used it on projects. The results were very good. And then we rolled it out across the entire company. We created a manual and a series of training exercises, and it failed. It didn't work beyond the group that was working with it originally. And then we've kind of reset, rolled back, and we've got some thinking about why it failed and what we can do to make it work better for the whole company, and not just the group that was using it before. So these are the things I could talk about, but this is really your time. And I want to be sure that you're getting the most out of it. That one of the things people say about lean is that it's the voice of the customer. What is lean? Lean is maximizing value by eliminating waste. Okay, that's easy. Well, how do you know what's value and what's waste? The typical thing people say is value is defined by the customer. You have to know the voice of the customer in order to know what value is. And anything that the customer will pay for is value, and everything else is waste. So for a car, a soft seat with no tears is valuable. The plastic that wraps it is waste. So Toyota's made a purpose out of eliminating waste. Today, you are the customers. So anything I say that isn't of value to you is waste. So use me as a tool and aim me and my work. I'm here to serve you. So let's see what we can do about maximizing value for you. So with that, I'll jump in. There are a couple pause points during the presentation, and I'll check in and we'll see how I'm doing with maximizing value. Does that sound pretty good? What do you guys think? And then in terms of the English, I'm okay, or do I need Ergo here to help me communicate? Or tell me if you don't understand something. I really like questions. Okay, so here's what was the last time I gave this presentation. It was to a group of diverse people, mostly contractors. I'm an architect. I've been practicing architect maybe close to 30 years. Lean's been a part of my world since about 2005, so maybe a dozen years. And in the United States, architects are very slow to adopt lean. The practitioners, the people who have taken to lean very quickly, are the constructors, and then to some extent the owners. And that's reflected in this group. Do you know what the group you're all studying? I think I've heard you're all PhDs, and you're studying, is it design, construction, project management? Help me out here. Project management. And the whole group is mostly project management? Oh, okay. I'm just going to write this down. So I like to write things down. So project management. Structural design, okay. Anybody else? Structural design, okay. Anybody else? You don't have to share if you don't want to. Project management, okay. Civil engineering, okay. Am I the only architect in the room? Okay, well, be nice to me. Do your best. So this is just a reflection of what I went through. There'll be a little bit of lean theory, and speed me up or slow me down. If it's stuff that you know really well, tell me to keep moving, or slow me down if it's new and you have questions. And then I'll share how we've applied it to projects and then some problems that we've encountered. So some good things and some bad things. So I think maybe the reason I'm here, or the reason lean has been part of our world is reflected in this slide. And I don't know, this is from The Economist in August of this year. I don't know, has anybody seen this graph? Good. Okay, Marco and Ergo. So this shows the value, the increase in productivity for a number of different industries in the United States. So the ability to increase value over time. It starts in 1947 and it goes to today. So if you look overall, value has slowly been increasing since then. In sectors like agriculture, manufacture, it's just gone through the roof. Our ability to have an hour of labor be relevant to the final product has gone way up over time, except for design and construction. So in our world, design and construction, we peaked in the mid-60s, and we are less than half as efficient now as we were in the mid-60s. It's a brutal graph, right? What we do now, it takes 2 hours of our time now to do what it used to take an hour of our time in the mid-60s. In manufacturing, the two pie charts on the right reflect the same thing. Manufacturing is much better at understanding what value is and how to get it into a product than design and construction. So that's a hard slide. The next one's pretty hard too. We're not very good at delivering projects on time, right? You can see the pie on the left, 70% are delivered late. Cost, 73% over budget. We're not very good. The project managers in the room, we're not very good at managing projects. We haven't figured out how to do that. And then on top of it, on the sustainability side, in the United States, design and construction is the second largest industry in the country. It's massive, and we have a very deep impact on the environment. We're the largest use of energy. Our greenhouse gas emissions are higher than any other industry. It isn't green. It's very difficult on the planet. So there are some things in our industry that could be a whole lot better, right? And the opportunity is to understand what those things are. And a very simple idea would be just to look at what other industries are doing to increase productivity and try to understand what could we just pick up and use in design and construction that would get us that kind of productivity and solve some of the big issues of our industry, design and construction. So now, this is a small group, so it might be hard, but usually I stop and ask if each of you, or maybe together, had 3 wishes for today. I think I have probably like 40 minutes left, and then some Q&A time. So 3 wishes, what would they be if you had a wish? To learn more about lean, to learn more about how bad design and construction is? Anything? And I'm okay moving on if you don't want to do the wishes. Sometimes we'll do like a big board.
How you do it in practical field.
So how does it work? Marco, see if I get this right. In the field? Yeah, that's a good one.
How did you get people on board?
Oh, I don't know. Yeah. I have some ideas. Those are maybe the 2 key ones. Anything else that you want out of today?
What's your prediction of the future about lean construction?
These are good ones. That would be an easy one for me to forget, so it's good to write it down.
What did we do right in the 70s, or what did you do right in the 70s?
Whew.
Then there was this peak in productivity in the construction industry.
Maybe we should have that over a beer. That's a good long conversation.
I want to add something to this question. What does the agricultural sector do right now?
Oh, what is
Is
the?
it successful? Is it regarding the new machinery? Or?
Oh, yeah. Anything else? These are good ones. I wish I had gotten these last night. Let me see, I will work to respond to them with this material, and then some things we may have to circle back to. So Toyota is a key piece of why the other sectors are doing well. And Toyota has had enormous gains. They've been able to accomplish things that other companies can't. They've been the #1 auto producer since 2007. Their growth curve is phenomenal. They've organized themselves and their processes in a way. Well, actually, even before that, they were doing stuff that other people said couldn't be done, right? Like as an example, for a car to be, luxury cars needed to be very quiet and very stable. And for years, they were heavy, which meant their mileage was very low. When Toyota came out with the Lexus, which was a car that was both very light and got very good mileage and was extremely quiet, they broke a rule that could not be broken. And manufacturers, people from the United States, people from the West, looked at what Toyota was able to accomplish and said, that can't be done. They're doing things that can't be done. They're getting their errors are lower than other companies. What are they doing? So they went to Toyota to study their techniques. And they learned a lot of things that Toyota was doing things that were very different than the way we do things in the West. And they came back with a bunch of principles and called them lean. Lean, Toyota didn't have the word lean in their vocabulary. They developed a way of working, a way of operating. People from the West came to study it and said, okay, these things are lean. And that was the birth of lean. But the truth is that the origins are kind of deeper than that. We know this just in time, stopping the line, built-in quality. These are all things that just couldn't be done with the way we manufactured before. Toyota changed it. We came back with those principles and called them lean. Lean got into construction a lot in my world through these two guys, Glenn Ballard and Greg Howell. And they were early adopters. I'm going to go back. This is just a few touch points on lean. So they took a lot of those principles that Toyota was using and worked to implement them on projects. And I was some of that early work, and some of it worked and some of it failed. But we used a mentality of just, we're going to study lean and we're going to try our best. This is back in the early and mid 2000s. We'll try our best to use it on projects, and we'll experiment. Will Lichtig, I don't know if anybody's seen this guy before. But he focused early on behavioral aspects of lean that were kind of driven a little bit by trust. You know, our early contracts with Sutter had these 5 principles in them, and they were as much about behaving in a certain way as they were using manufacturing tools. I really like this quote from Ono, who is said to be the father of lean in Toyota. You should submit wisdom to the company. If you don't have any wisdom, submit sweat. If nothing else, work hard and don't sleep, or resign. So what is lean, and what does it really mean? The truth is, in our work, I think we've come to 2 things. It's a philosophy, so an underpinning sort of cultural piece, and a system, and a production system supported by some simple tools. And our understanding continues to evolve. I'll tell you this, we went hard, and you're going to hear it in my words today, on the tools, trying to understand the tools and how you use them in a project. And we are now kind of circling back to the philosophy, the cultural aspects of it. So I really like that question, how do you get people on board? Because there's a piece that's training people how to use tools, and there's another piece that's much more complicated. So if you look on the Toyota website and you dig through their mission, what their values are, it isn't return value to shareholders or build the best cars or that sort of stuff. It's these 2 things. So these are the 2 underpinnings of Toyota, the business, right? So they're big for profit, they're massive in the world. Their 2 things are continuous improvement, so we will always be able to do it better. We're never perfect, we're always improving, and respect for people. That the people who are doing the work know the best way to do the work. If you compare this with General Motors or any of the other big auto manufacturers, it's wildly different. And there's nothing in here about tools. they're hinted at, but it's fundamentally a philosophical orientation about the strength of the people themselves. Just a little background on production. It's been said there have only been 3 production systems in the history of humanity. The first one, illustrated here, is the craft production system. So a craftsman in that production system knows everything about the thing that he or she is making and has the ability to do all the work. So in the early days of automobiles, it was carriage workers who would do the woodworking on the outside. They would do the metalworking of the axles and the wheels. They would stitch the leather for the seats. They would do everything. Violins are built this way. That craft production system is still going on. It's very expensive per product, and the quality is very, very high. So that's one production system. Henry Ford is credited with creating the mass production system. And the big idea behind mass production is that the item is broken into components that are then farmed out to different business enterprises. So in the automobile example, the distributor is made by somebody different than the wheel, that's made by somebody different than the tire, that's made by somebody different than the steering wheel. And the ability, once the person began focusing on the component, the cost went way down. Unfortunately, the quality did too, because you took a holistic thing, broke it into subcomponents, and allowed each component to be optimized at that level. So what happened is the components don't always connect together too well. So the quality went down, the cost went down. So Toyota's system, Lean, is the third model, where you have the separate business entities connected together around the same product. So you still have different groups doing different things, but they all sink or swim together. They're one business unit, or if they're multiple units, they're incentivized according to the performance of the whole thing. And the quality has come way up relative to mass production. Probably doesn't approach the craft system, but the quality's come way up, and the cost is about what mass production is. Any questions here? Is that? So in our work, as I said, and I'm happy to skip around if there are questions or anything. So in our work, this is an early project, 60, 70,000 square foot office building in California, where we used these lean production tools. So we went to Toyota, we learned how they produce things, value stream mapping, just in time, all that stuff, and we applied them to this project. And the application of those production tools failed. Right? Because design is not a linear process. Design is more iterative, and design is different than manufacturing. So we went back and studied not how Toyota manufactures things, but how they design things. And that's the bulk of what I'm going to talk about today. We went back and we learned as much as we could about lean design, and we had already studied, and it's well documented, production management. We put those two things together, and we think about the life of a project being having a design piece that uses a different set of tools borrowed from Toyota for design than the manufacturing side. And together, we've put that together into this integrated lean project delivery. So if you only remember, well, I would say 2 things to remember from today, and this is one of them. The second one is that cultural piece that I'll talk about at the end. But the first one is that the design in the lean world is not the same as manufacturing. Okay? So just repeating some of that stuff. Production management, it's transactional. There's a recipe and a predicted outcome. You can perfect the flow and analyze each step of the process to reduce waste. It's predictable. You know where you're going. Design is not that, right? Design is really about maximizing innovation, creativity in a short period of time. Our first failure for Fairfield was saying if we had 3 options and only one of them went forward, the other 2 were waste. It's better to just have one option in the manufacturing world. That is really not true in the design world. So we learned from that, and we studied quite a bit of how Toyota, what their design process looks like, and we implemented some stuff from it. Make sense? Okay, so the 2 things are different. There's a guy, let's see, I'm going to skip around here and see if I can find it quickly. Look at all these. And again, so this is a book. Michael Kennedy, you can't read it. Michael Kennedy is an author who went to Toyota to study how they design things. And he wrote a book, Product Development for the Lean Enterprise. Has anybody seen that here? Okay, good. So he spent time studying Toyota and came back with these 4 principles of how they design things, not how they manufacture things. And these are, I'm pulling some of this stuff out. So the 4 principles are an entrepreneurial leader, responsibility-based planning and control, expert workforce, and then set-based concurrent engineering. So these 4 things, you got to have a leader who is nimble and able to guide people and create a vision, get them to follow. You got to have a system where everybody takes responsibility for their work. You've got to have workers who know what they're doing, and then you do this thing called set-based concurrent engineering. So he said, if you do that, these are the 4 pillars of lean in the product development area. And what I'm going to do now is what we did as an organization. We said to ourselves, okay, we got the leadership, we got the expert engineering workforce. We're going to go hard on responsibility-based planning and control, and we're going to work hard on set-based design. We're going to learn what these things are and try to implement them. So relative to both of them, a key piece, has anybody seen this curve before? Okay, okay. So this is time, right? And this is the amount of effort that goes into a project, into a building project. So over time, this is pre-design, SD, DD, CDs. This is over time in the project, typically is the yellow curve. So over time, the workforce grows, you get more people involved and more knowledge, until you peak pretty deeply into the project. This is the way 90% of all work in the United States occurs. So the problem with that method is your ability, this green dashed line, this is your ability to make changes. So in the beginning, you can do anything you want, but as time goes on, your ability basically disappears. And the big conflict is that as your ability is going down, your knowledge goes up, and you learn what needs to be changed after your ability to gracefully change it has passed. This is the fundamental problem with construction in the United States. So what we've done, what these techniques are kind of key to them, is the idea of pulling that curve forward, getting the knowledge in place at a time when the project can respond to it. So a key piece of that is pull planning. So this is responsibility-based planning and control. Again, you got to forgive me, I'm going to ask for hands a lot. Pull planning, any exposure to this stuff? Okay, so pull planning is an idea that's a little bit backwards. Instead of having a project manager in a room creating a schedule and forecasting who is going to do what over the life of a project, pull planning starts from the end, what the first patient in the bed might be the end of the project, and then works backwards. What are the milestones? What are the big things that need to happen in order to get that in place? You know, before the first patient, there's staffing and stocking and licensing. Before that is the certificate of occupancy. Before that is the final technology install. You work back in milestones in big chunks, and then you get the whole team together to understand the specific tasks that are needed to get to each one of those milestones. So pull planning is backwards, and it involves a group, so everybody's understanding what needs to happen. As opposed to a project manager making predictions. It's backwards, it's done as a group, and then it's live. We almost always use stickies, use Post-it notes to track who's doing what. And we track whether or not the task has been accomplished as we go. I think I've got a shot. I'm going to skip back to that because it's kind of, this might be simpler to look at. But this is showing day by day in a week let's see, I'm going to write on the board again. So if we start with the end, and then we work our milestones back, this is kind of, again, the big group figuring out the milestones of the project. We pick a milestone, the milestone that we're closest to, we then create these tags. So it's important to know that this duration of all these tags, this is like 2 to 4, 5 weeks max. And the reality is some of these tags end up drifting out here, but you really do this kind of detailed work in over a short period of time. You don't try to predict 2 years from now what somebody's going to do. You do have the milestone, so licensing. You know what that is. But you do the detailed pull planning off of a close milestone. This is a really important part of pull planning. And then you manage that very, very carefully. If we look at, okay, so here we go. So a tag, each of the tags, the way we use it, each tag has who's doing the work, who needs the work, who the customer is, this would be me doing the work, this is who needs the work, what I'm going to do, the task at hand, and then what I need from other people. And then it's also got how long it takes, the duration, and when it's due. So each of these tags captures that amount of information. So if I'm drawing an elevation, if I'm drawing an elevation for Marco, then perhaps I might need from the structural engineer an understanding of what the members in the perimeter wall are so I can figure out where to have my windows. And that would trigger another tag by the structural engineer who's going to deliver to me a schematic level understanding of the structural system at the edge. And to do that, he or she may need a decision on whether it's moment framed or brace framed. So that may come from the planning team, so on and so forth. Does that kind of make sense? I feel like if there are any questions, shout them out. Okay, I'm gonna keep going, and I'm a little worried. Oh, look at that. Oh, now I'm very worried about the time. Wow, that's amazing. I've never seen that. Huh. I'm going to take that as a good sign. Something's going on. Okay, so that's how pull planning works. These are days. These are tasks with those tags on them. These are tasks that have been completed. This, we track our performance of who's accomplishing what over time. So this is a weekly performance. These percentages show how many tasks are complete. When we miss a task, we track why we missed it. So I overcommitted, I had too much. Miscommunication, I didn't understand. The previous work wasn't complete. We tracked the variance code, why it didn't happen. And this system works pretty fantastically. You could see here, these are what work is getting accomplished by week. This was the week of Christmas. You could see the product just fell off. We were very mistaken in predicting what we were going to get done. So this tool is worth learning a lot more about. This is a very, very, very powerful tool. I'm only going to talk about 2 tools today. And oh, go ahead.
Why have you planned some tasks or activities over Christmas? It's like the production is planning something over lunchtime.
Yeah, yeah. It's I mean, this project has fantastic results, and the team knew the tools very well. The culture and the philosophy of the team was very, very good. And they really understood the need for the first patient in the bed. The hospital was seeing patients in corridors. And they were so driven by that they overcommitted themselves. So the variance codes on these is one, they overcommitted themselves. And I'd say it's the will of the team to really, I'm going to get that done. And they overcommitted themselves. But this is a learning thing, not a blaming thing. You know, the learning is to not overcommit. I respect and admire the will of the team to try to do that. So this is a tool that we use that I'm not going to go into to plan those tasks. So I'm just going to skip that for now. So this is a little bit on the first thing, pull planning. The second tool that we looked really, really carefully at was set-based design. Anybody seen any of this stuff? All right, so I can just make stuff up. So on the left is what design always looks like, right? As an architect, I come in with multiple options, and we pick one, and then we develop it. And best case, we pick that option very, very early before, say, structural is even involved, right? The earlier you pick that, the better it is because you have less fooling around. And what happens is as you learn about the project, you get stuck going backwards. It costs too much. I didn't leave enough room for columns in the elevation. And you get stuck in these iterations, and it drives an enormous amount of waste, and it's a key piece of why our results look the way they do. So Toyota's set-based design process is wildly different. They break the project into components, and then they keep the components open as long as they can. Instead of picking an option early, they pick an option very late. They don't pick an overall option. They pick a component level option, and they only pick options at these integration events where the whole team is together. So it's wildly different. There are two, maybe a quick time check. What time do I have until?
So now it's 4:15.
Am I supposed to be over?
Oh, 20 minutes.
20 minutes? Okay. I'm gonna hop around after this segment and try to leave some time. How much time would the group like for questions? 10 minutes? 5 minutes? Do I talk to the end? I could stop now?
Let's have like
Or continuous?
3 questions.
2 to 3 questions? Okay. Okay, well, I'll talk and stop. So set-based design is a hugely important thing. Of the tools, the 2 big ones are pull planning and set-based design. So you make decisions very late, and you make them as a group. This is some math that shows if you have 3 bicycle options versus 3 wheel options, 3 crankshaft options, 3 handlebar options, you have many, many more combinations than you do 3 on your own. I think the group kind of gets that. There's a story, a parable about 2 watchmakers. I don't know if anybody's seen this. They are very good at what they do. There are 1,000 pieces in each watch. When they get in, they are very good, so they get a lot of phone calls. When they pick up the phone, they drop what they're doing and they destroy the work that they've done so far. One watchmaker has taken all those pieces and broken them into groups of sub-assemblies of 10 that are then combined. 10 of these are combined into those to make one watch. And the first one just makes the whole watch. The first one goes out of business and ends up working for the second one. Because when you work in this method at the subcomponent level, you have a lot more reliability than you work in the method that's on the left. This is an example of set-based design at work for us. We're showing different floor plan layouts here. These are the criteria that we've established in the beginning of the project for success, and then how the criteria perform against each one of these. So in this methodology, we'd study the floor plan separate from the design of the room, separate from the materials that are used in the hallway, and we evaluate things and make recommendations about what to go forward in a way that everybody can understand. Does that make sense? So set-based design, the 2 things, well, maybe 3 things: make decisions as late as you can, and the pull plan tells you when you need the decision. Make decisions as late as you can. Work at a subcomponent level, work on the handlebars, the tire, as opposed to the whole bike, and do it in a way that's transparent, that everybody can see, at this point, this was the best option. 2 weeks later, it might have shifted to another option. So those are kind of the 2 big things that we used on that project: set-based design, pull planning. And the truth is, there are a lot of tools, A3s, CBAs. These light blue things are all lean tools that support these different areas of the set-based design, the responsibility-based planning and control, the expert workforce in this. So we spent some time, we learned how to use these tools, we experimented with them on projects, and we had some really great results. And I want to say, in our world, for my company, there's a design piece of it. There's a delivery piece where we shift back into the manufacturing aspects when we're delivering the project. And then we also focus on operations. So we work with our clients to use lean techniques to help them operate in a better way, whether it's delivery of education, teaching students, or healthcare, making people better, or utilities. So as I said, the results from doing that are good. And maybe I'll just skip through these because I want to be mindful of the time. That project that I talked to you about in the beginning, the Fairfield Medical Office Building, the budget started off at $22.25 million. We finished the project on time for less than, less than 20 million. And we added scope to it. This is Sutter. This is a big healthcare organization in California. They had something like 32 projects going at this time. This was a time of rapid escalation. So of their 32 projects, only 2 of them were on budget, and only 1 of them, this one, was below budget. So this was a very, very, very difficult time to be building in California, and we beat all of their other jobs using those techniques. Here's another Sutter project. They asked us to design a hospital that was very efficient and did 5 things. They asked us to increase throughput. So they asked us to move 50% more patients through the hospital in the same amount of time, in a certain amount of time. They asked us to reduce the staff count by 40%. So move half again as many patients through, 40% fewer staff. Do it in a facility that's 30% smaller. Build it in half the time that it typically takes, and then cut the natural resource use by 25%. And using those tools, we beat all those metrics. So it's working at a subcomponent level and being very focused, very aligned on those things. Our team had a pretty phenomenal outcome. This is a very large project in California where I'm going to maybe skip right to the end, where we drove the cost down from $7.5 billion to $5.7 billion. So we saved, what is that, $1.8 billion in construction using those same techniques. This is an artifact from that project. This shows breaking the components, the project up into these 5 components, and each component was staffed by a cross-discipline team, by a multifunctional team. There were engineers, architects, healthcare people, administrators. It was a phenomenal success. Here's another project, that Spring Valley project that I mentioned before. We were looking at the pull plans from regarding time. It was when we started the job, the CEO, this is him pretending to lift this topping out beam. When we started the project, he set a goal to deliver the first patient 2.5 months earlier than the schedule. And we ended up not just hitting 2.5 months earlier, but getting a month ahead of that. So we beat the original schedule by 3.5 months. This is an 18-month schedule, so huge. And it started $3.8 million over budget, and it wound up $2.8 million under budget. So we used those tools that I just walked us through. Well, let me give you one more. So design is a big piece of my world. And this is using those same tools. This is a project for a community college, for a junior college. So this is a very, very tight budget project. It's super sustainable. It's a lab and science building. We used the same tools, and we worked very, very hard in a design build, low budget environment to deliver just an outstanding project that looked and functioned fantastically. We have a pretty prestigious organization in North America, SCUP, and every year they give a very limited amount of honor design awards, design honor awards. Last year there were 3. Harvard got one, Stanford got one, and our community college project got one, which is phenomenal. I mean, the budget we were working with is nothing compared to the other projects. So we've had big success in design using the tools. We've had big success in budgets. We've had really big success in schedule management. This is the best, right? We've learned how to do this stuff. We've worked it out on projects. We've seen the results. So what we did as an organization, again, we're like 800 people, is we decided we're going to roll this out as an organizational strategy. So we created a manual that captured the different tools and how to use them. We established training sessions. We connected it with our strategic plan, so kind of our big vision for the company. We ran training sessions across the country. In all of our offices, we trained our staff on how to use these tools. We set up a network to be able to share this learning back and forth across the company. We captured A3s. I don't know if anybody's seen that, a brilliant tool that I'm not going to go into now, but we captured A3s to be able to share back and forth across the company. You can see, all these different projects and their A3 reports in here. And it was the best. We did a fantastic job rolling this out. And the truth is, it wasn't the best. It failed completely. It did not, the projects that had embraced Lean and were using those tools, those teams continued to do very well. The rest of the company it had basically no impact on whatsoever. We did a lot of work, pulled together a lot of good material that was really complete waste in terms of communicating that value to everybody. And so where we are now is we're trying to figure out what happened and what might we do about it. For sure, we have experienced better ways to deliver projects. And for sure, we are not getting that out to the whole company. Our thinking, where we are right now, is that our system, our structure, is very hierarchical. And the reality of the way the teams that are using Lean is organized is a little different than that. I think now is going to be I'm going to start skipping around here in a minute. A different way of saying it is that we were designed as if we were a complicated system, as if projects were complicated, and the reality is they're complex. So the difference is a complicated system has a lot of parts to it that work in very predictable ways. You move a lever here, something else moves here. A complex system has a lot of parts, but they work in unpredictable ways. You can't predict the pull plan 3 years out, who's going to do what on a certain day. Things change constantly. I heard a good expression, if you're a sailor, well, if you're a motorboat and your course is 330 degrees, you're almost never at 330 degrees. You're always adjusting very slightly. And that ability to handle the complex is what Lean is so good at. We tried to roll it out in a way that was very organized, as if we were rolling it out in a complicated system, which the structure of our company used to be. Any questions? And I'm going to do my best in maybe 5 minutes to try to wrap this up. So we've talked a bit about what Lean is. We've talked a bit about some results that are really outstanding of teams that are using that. We've talked about our goal of rolling it out as an organization. And now here we are in this last section. What do we have in here? Maybe I'll hit a couple of these and not smoke all our team. Yeah, so here's just kind of another shot at it. And this is from McChrystal. He was an American general who led the invasion of Iraq. And he shifted the organization of his team, so this is a huge amount of soldiers in Iraq, from a hierarchical system that's represented in the upper left to a different kind of structure that's represented in the upper right. So we have begun that work in our company. We still are, organized into practice groups that had pretty clear lines of accountability and responsibility. And we are working to merge to create a system where people are connected people to people rather than kind of up to the top. And it's a mixed bag. It's not a mixed bag. It's a work in progress. This is work that we're doing. Where we are is we had earlier on, we'd focused on the pull planning, responsibility-based planning and control, the set-based concurrent engineering, and we thought we had the workforce and the leadership kind of in the bag. We thought we had that. And the truth is, we had missed those two key aspects of those two fundamental things, the continuous improvement and respect for people. So where we are as an organization is working hard at that. You know, our leadership style, I think, is changing as an organization. This is a neat, simple way of looking at it. There's one model where the leader tells everybody what to do. There's another model where you do whatever you want. And then this Lean style is trading off that leadership and really doing it in the spirit of learning and figuring things out together, as opposed to judging and even blaming, do this, and if you fail, it's your fault. This is the CEO of our company. I'm on the board of the company, and this is us at work kind of reorganizing the company. And this diagram is showing our different market sectors and identifying aspects of each one that really need to be connected to each other, and then beginning to brainstorm about how we're going to do that. So I don't have an answer to the cultural aspect, but it is work that we're doing right now. And then there is some interesting thinking going on that we're using on projects about ways to get designers more engaged in that. But I think I'm going to pause before getting into that. So the questions that were, how does it work in the field? And I feel like I've talked through that a little bit. We saw some very specific examples of two really important tools, and then results of using it. There might have been, was there a result thing? No. How do you get people on board? This is really stuff I think about a lot. And we kind of had, if we had multiple steps, maybe our first version, we had people who wanted to do lean, who were kind of wired that way, and then we learned how to use the tools, and we had really, really, really good results. The second step, we tried bringing the tools to people who weren't wired that way, and the results kind of didn't happen. This first group of people kind of continued on and have continued to do well, but the next group of the company, it's just not, of the organization, it just isn't spreading the way it did with these people. So the third piece that we're working on right now is really this, and it's trying to, our focus is on the people, and trying to strengthen that while maintaining, of course, the tools. But we're putting our energy into how do you get people on board. What do I think the prediction is? I think it's going to be this. I think that as architects, actually all of us, designers and constructors, our industry is changing, and a lot of our work is being taken over by other people. We have tech startups that are jumping, like Adidas, that are jumping right into design and construction. So I think that the better way is going to be found, and if we sign on to these tools and techniques and behavior, it's going to be us that finds it. What did we do right in the 70s? That would be a good beer conversation. We've talked a lot about it. In the United States, litigation and all of that legal stuff is an enormous drag on our industry. We do a lot of work just to be safe in case we're sued for a project, and we're almost never sued on a project. So for sure, that's one form of waste, but there are other ones too. I think our world was a little simpler then too. Our teams now, you saw the one from that $1 billion project. Now we have teams of like 50, 70 people. It used to be projects used to be much simpler. So coordinating that many people is just a different thing now. And then why are other sectors successful? I think speaking as an architect, when I look at other sectors, I sort of admire the clarity with which they approach their work. There's kind of a business side to manufacturing, or even a business side to product development, and people understand what success looks like and what it doesn't. The architectural world is much squishier than that, and I think alignment is something we talk about a lot. Alignment as a project team and alignment as an organization, and very frequently we find ourselves in a place where either the team is not aligned, and they have each person or group of people will have different goals, and I think alignment is a key piece of why other sectors are successful. Once you're aligned, you could do something like look at lean tools and how they work better in other sectors, and you could say, I'm just going to pick it up and do it. For architects, it's a little more complicated. All right. Any other questions, Marco? I know you've got a piece, and I want to be respectful of your time.
Thank you, Stan, very much. So now we have some time for questions. Stan, other ones?
Or if you, and they don't have to be questions too. It could be comments or advice for me. Yeah.
Do you have any specific software you're using to build this?
Yeah. So, so the question is, any specific software to use? So, yes.
Or only stickers?
Only stickers. Well, so I think that one of the deep ideas of Lean is to get people from different areas integrated and working in a common direction. So BIM and Revit early on evolved to be a very, very good tool at getting people to talk to each other. You could, instead of working in the field with welds, you could do it virtually and understand where conflicts were. The pull planning with stickies is a great way to get people to talk to each other. That has evolved into a series of different pieces of software, from Visio, which kind of graphs that and gives the ability to see it in multiple places, to vPlanner, which kind of gets into the model and then begins to track. You could see how many tasks you have, when they're coming, all that sort of stuff. So the software is really, there's software evolving to support that kind of communication. Lots of times, this is a good expression, the simplest tool is the best tool for any given job. It really is. So if the goal of the tool is to foster communication between a diverse group of people, oftentimes a sticky note, if they can all be in one place, is the best way to do that. So, but for sure, there are systems evolving. Any other questions?
Is there any hope in approaching these car manufacturing fields and so on? Because construction as a whole, it's still tailor-made.
I know.
It's
Yeah.
coach building.
Yeah.
They do 100 of different models, and that's about it. But every building is different.
So Toyota, one of the things people say about Toyota is when they got started, they came to World War II happened, right? And their country is just in shambles, and they have no infrastructure, and they're in a very rough situation. They came to the United States to look at manufacturing. They saw mass production and were stunned. You know, this is amazing. But it's 1,000 versions of this model, 5,000 versions of this model, 100,000 versions of this model. And they said, there's no way we can do that, you know, because we have so few people that there's all this, it's almost like everything is custom. So they came up with a system that allowed them to, they call it mass customization, that allowed them to have components that are consistent between different things, different models, but other stuff that's different. That's the answer for design and construction. In that set-based world, some of those alternates will be reused from other projects. You've already got them in place, and other things are brand new. Software is organized this way. Coding is done, by and large, in a component level way. So a code will have components that are pre-baked and used from other code, and they'll be either assembled in a different way, or 3 of them will be pre-baked and 2 of them will be brand new. We don't work that way in design and construction, especially on the design side. Every time we do something, it's brand new, and it's killing us. That's why that curve looks the way it does. So I think that's the hope.
And it's like 1 building per year. So
yeah.
to build this kind of database, you would need to live how long? 1,000 years?
Well, but it's true. And then even worse, the team that builds that and gets all that knowledge breaks apart. You know, at least in the United States, they break apart and then you get together. Even the architects, the designers, will have a completely different team and will be with different engineers and different contractors. It's crazy.
So it's hopeless.
Well, systems are emerging that are different than that. So in China right now, there's this massive emerging middle class. It's 2 Chicago's worth of infrastructure every year is needed by that group. So there's a crazy, that is, I mean, I think too, 1 building a year and then 5 years later I'll build the next one. But the reality is these buildings are getting built over and over and over and over. And there are some small things, site or culture, that will change them. But a lot of the components could be the same. All right. Thank you.